In previous chapters, we have looked at solids and solutions. This chapter, we're going to focus on gases, the variables that we need to consider when working with gases, and also how to use these variables when considering chemical reactions. There are suggested problems for you to look at the end of the chapter to make sure that you understand the concepts being covered. The odd number problems have answers at the end of the textbook. So you may have experienced one of the variables that we talk about when we're talking about gases, and that is pressure. If you've ever been traveling and gone from a lower altitude to a higher altitude, either in an airplane or in the mountains in a car, you'll notice that there is a change in pressure. So at lower altitudes, the pressure is higher, there's more gas molecules present. When you go to a higher altitude, there are less gas molecules present. The difference in pressure gets to be felt in your eardrum because when you're used to a higher pressure, the extra molecules of gas end up behind your eardrum, pushing it out. When you equalize that pressure is when it is called, or when you refer to it as having your ears pop. So the pressure of a gas depends on many things. It's a result of that constant movement of particles and their collisions with things around them. It does depend on the number of particles in a given volume, so that will be moles. It depends on the volume of the container and also the average speed of the particles. And that average speed is related to the temperature that those particles are at. When we talk about pressure, there are lots of units that we use, and this can be confusing because when we're talking about mass, we refer to grams. When we talk about molarity, we refer to moles over liters. There's only a few units that they can be. But when we talk about pressure, we are talking about, it can be measured in pascals, it can be measured in atmospheres, millimeters of mercury, pounds per square inch. And so there are lots of different units, and being able to recognize these units as pressure is going to be important. The ones that we're going to focus on are atmospheres. So we are going to be converting to atmospheres in order to use the equations in this chapter. Most frequently, it is going to be converted from millimeters of mercury or torr. These are the most common units that we use. But in the United States, you might see inches of mercury because this is what atmospheric pressure is measured in. You also are probably familiar with pounds per square inch because this is a unit that we use for inflating tires or other things like that. The conversion that is really important to know is the millimeters of mercury and torr. So these would be handy ones to remember, converting into atmospheres. So let's try an example. We've got a racing bicycle tire that has a pressure of 132 pounds per square inch. We want to convert that to millimeters of mercury. We know that this is a racing bicycle because this is a very high pressure, which allows the wheel to come into less contact with the road, reducing the friction. So when we're doing these problems, 132 psi, I frequently convert into atmospheres and then from atmospheres to whatever other unit we need. So 14.7 psi is 1 atmosphere. And then from atmospheres, we can convert to millimeters of mercury, which is that 760 millimeters of mercury is 1 atmosphere. Our PSI will cancel, our atmospheres will cancel, and we'll end up with millimeters of mercury. So 6,820 millimeters of mercury is equal to 132 psi. Here's an example for you. Try to convert from psi to kilopascals. Pause the video and do your conversion. So from psi, we are going to convert to atmospheres. From atmospheres, we can then convert to kilopascal. So 1 atmosphere is kilopascals, 101.325. So multiply across the top, divide by anything on the bottom, end up with 314 kilopascal.